We now have our slopes working, so it's time to start adding the remaining states. We'll be starting with our dashing state. To do that, we'll need to first add an input action for our dash. So open up the docked input actions window. In here, add a new action and name it dash. I'll leave the action type as button. Make sure you remove the clamp and invert processors Unity automatically added from our previous input. I assume it's a bug. For our binding, I'll bind it to the Shift key. We'll also add another binding and set it to be the mouse right click. This is simply because you can dash with any of these two keys in Genshin. When you are done setting the bindings, feel free to save the asset. Still in Unity, open up the grounded states folder in the player scripts folder. In here, we'll create a new C# script, which I'll name player dashing state. Open it up and remove the default methods. Swap the inheritance with player grounded state instead, and generate the constructor. We'll need to cache this state, so open up our player movement state machine script. In here, duplicate one of the properties and swap it with the dashing state. Don't forget to initialize it as well. When that's done, go back to the dashing state script. When entering this state, we'll have two possible outcomes. When we dash while moving, which is the equivalent of transitioning from a moving state to the dashing state, we'll dash towards our movement direction. When we dash while standing still, which is the equivalent of transitioning from the idling or the stopping states to the dashing state, we'll dash towards the direction that our player is facing. To do that, start by overriding the enter method. If our dash comes from a moving state, we'll simply update the speed modifier to be a bit higher. If it comes from a stopping state, we'll add a force instead, as our player isn't able to move without pressing a movement input key. Of course, that means that we need a speed modifier value, which also means that we'll need to create a dash data script. So, back in Unity, go to the states data folder, and in the grounded folder, create a new C# script, to which I'll name player-data. Open it up, remove the default methods and the inheritance, and make the class serializable. Then add a speed modifier by typing in field, serialize field, field, range, from 1f to 3f, public float, speed modifier. I'll give it a private set. I'll also default it to 2f. Then go to our player grounded data script. In here, create a new field, serialize field, public player-data property named -data. I'll give it a private set. We can now return to our player dashing state script and set the state machine.reusabledata.movement speed modifier to be equal to movementdata.dashData.speed modifier. We'll be needing more data from this class later on, so above, create a new variable by typing in private player-data-data. In the constructor, set the -data to be equal to movementdata.dashData. Then swap it in our enter method. This does it for when we are transitioning from a moving state, so for the from a stopping state case, we'll call in a new method named addForceOnTransition from stationary state. I'll add this method to an iteration named main methods. I'll also add the enter method to an iteration named iStateMethods. In our new method, we only want to add a force if there was no input by the time we got into the dashing state. So type in if statemachine.reusabledata.movementInput is different than vector2.0. If that's the case, then we can return. For the force, we'll add it towards the player facing direction multiplied by the movement speed. To do that, start by typing in vector3 character rotation direction equals to statemachine.player.transform.forward. We only need our horizontal rotation direction, so now type in character rotation direction.y equals to 0f. Here we'll actually set the force to the velocity variable of the rigid body. The reason why we'll be doing that is because we can move while dashing. That means that it is possible that our move add force will be called before dashing. Even if we were to reset the velocity before we add this force, it's possible that it will reset, add movement force, and only then add the dash force. Which again, because we are adding, it will become double the velocity. For some reason, doing the same as in the move add force of getting the player horizontal velocity and subtracting it from the add force only removed half of the velocity it needed to remove. I couldn't really understand why, which is why I decided to set the velocity variable right away, which seems to fix our problems, as it completely overrides the current velocity. So type in statemachine.player.rigidbody.velocity equals to character rotation direction multiplied by get movement speed. This should be enough to get the base of our dash working. However, in Genshin, if we dash twice in a small amount of time, we'll get into a cooldown where we can't dash for a second or two. We'll be calling this limit our consecutive dashes limit. The way they will work is as follows. When we enter our dashing state, we'll save the current time into a variable. Before we save that time, we'll check if the current time is less than our saved time plus a time we have defined, which is a time to be considered a consecutive dash. If the current time is less than that sum, then it is a consecutive dash, so we add 1 to the consecutive dashes count. Whenever that count is equal to the limit of consecutive dashes we have defined, we'll disable the dashing input for a few seconds. We'll be setting this data in our player-data script, so open it up again. We'll need 3 new properties, so duplicate the existing one 3 times. We'll name the first one time to be considered consecutive and default it to 1f. We'll also set its range to be from 0f to 2f. We'll name the second one consecutive dashes limit amount and make it an integer. We'll default it to 2 and make the range be from 1 to 10 without the f, as it's no longer a float. For the third one, we'll name it dash limit reached cooldown and default it to 1.75f. We'll also change the range to be from 0f to 5f. When that's done, head back to the player dashing state script. We'll start by creating our saved time variable, so type in private float start time. Then we'll create one to count how many consecutive dashes we have done, so type in private int consecutive dashes used. In our enter method, calling a new method we'll create named update consecutive dashes. I'll add this method to the main methods region. Inside, we'll start by checking if the dash we are in is a consecutive dash. So type in if is consecutive and generate the method. Inside, we'll return time.time, which is the current game time, lesser than start time, which is the time of when we have entered the previous dash, plus dash data dot time to be considered consecutive. So if we enter the current dashing state not too long after our previous dashing state, we'll consider the current dash a consecutive dash. That's done, so in our update consecutive dashes method, we'll add the not operator to the if statement and reset our dash count if it's not a consecutive dash. We do that by typing in consecutive dashes used equals to 0. After that, outside of the if statement, we'll add 1 to the used dashes count by typing in ++ consecutive dashes used. We now need to check if our used dashes count is equal to our dash limit amount. So type in if consecutive dashes used equals to dash data dot consecutive dashes limit amount. If that's true, we'll need to reset our used dashes count. To do that, type in consecutive dashes used equals to 0. This is likely not necessary if our cooldown is higher than the time to be considered consecutive, but this makes it a safe reset. We'll also need to disable our dash input for a few seconds. Unfortunately, it doesn't seem like the new input system has a built-in way of disabling an input for an amount of seconds, so we'll need to do it ourselves. We'll do that in the player input script. In here, we'll create a new public void method named disableAction4 and pass in an input action named action and a float named seconds. Don't forget to import the necessary namespace for the input action type, which is the type of our movement input, dash input, etc. Simply put, in this method we'll disable an action for an amount of seconds. We could add a list of inputs that we wanted to disable and then iterate through that list in the update method to see if we should enable any again, but we'll instead use a coroutine. This is simply because in this use case, it seems better for me to use a coroutine than to loop a list of disabled actions every update call. So, under our method, create a new coroutine by typing in private IEnumerator disable action and pass in the same parameters as above. Import any necessary namespace for the IEnumerator type. Inside, we'll disable the action, wait a few seconds and then enable it again. To do that, simply type in action.disable. Then type in yield, return, new wait for seconds, and pass in seconds. And then we enable the action again by typing in action.enable. That's all we need to do, so in our public method we'll call this coroutine by typing in start coroutine, disable action, and pass in action and seconds. In case you didn't know, coroutines can only be called in a monobehavior class, which is why we are doing it here. With that done, go back to the player dashing state script. We can now call in statemachine.player.input.disableAction4 and pass in the action of statemachine.player.input.playerActions.dash and the seconds of dash data dot dash limit reach cooldown. All that's left to finish this up is to set our start time variable value. We'll do this after we update consecutive dashes because we need to know the start time of the last dash and not the current one. If we did set it before we check if it's a consecutive dash, then we will be comparing the current pass time with itself, which will always lead to the same result. So in our enter method, right after we call the update consecutive dashes method, type in start time equals to time.time. We are now finished adding consecutive dashes, but we of course still need to add the transitions to and from this state. We'll start by adding the transitions to the dashing state. If we take a look at our movement system states, the states that transition to the dashing state are idling, all moving states, all stopping states, and the light landing state. In other words, every grounded state besides the dashing state. The reason why the dashing state doesn't transition to itself is that in Genshin, if we try to dash, we can actually only transition when we enter the sprinting state or the hard stopping state. It's a bit hard to understand it as the dashing state only happens for quite a small period of time, but if you keep pressing shift on that period of time, it will not dash again. So, knowing that, let's go to our player grounded state. Then in the add input actions callbacks method, call in statemachine.player.input.playeractions.dash.started plus equals on dash started. I'll also remove the callback in the remove input actions callbacks method. When that's done, I'll make the method be protected virtual and add it to the input methods region. I'll also rename the parameter to context. Inside, we'll simply update the state to be our dashing state. So type in statemachine.changeState and pass in statemachine.dashingState. Of course, right now this also adds a callback to the dashing state, which is why we've made this a virtual method. So open up the dashing state again and add a new region named input methods. In here, override the onDashStart method and leave it empty. Regarding the dashing state transitions to other states, if we take a look at our movement system states, at the end of the dashing animation, we can transition to the sprinting state if we keep holding the movement input key, or to the hard stopping state if there was no movement input key pressed. We can also transition to the jumping state. Of course, we still don't have our stopping states, so we'll instead transition to the idling state, and won't yet transition to the jumping state either, as we haven't done it yet. However, as I've just said, these transitions will happen at the end of the animation. The way we'll be doing that is by using something called animation events. Simply put, we can add an event at a certain frame of the animation in the Animator tab, and call a specific method for when our animation enters that frame. That means that we won't actually be able to test our transitions to those states until we add animations, but we can at least start creating the methods that we'll need to call in our animation events. To do that, we'll add 3 new methods to our states, so open up the iState interface. The methods we'll be adding are public void onAnimationEnterEvent, which we can use for things like make the player immune to damage when the animation enters its first frame, and public void onAnimationExitEvent, which we can use for things like make the player vulnerable to damage again when the animation enters its last frame. In Genshin, an example of this will be the character's ultimate ability, which makes the character immune to damage when the animation is playing. For our last one, we have the public void onAnimationTransitionEvent, which we can use for transitioning to other states when the animation enters a certain frame. An example of this will be our dashing state, which is the reason why we are adding these events right now. When that's done, open up the player movement state script. In here, implement the 3 new methods we have added. I'll add them at the end of the iState methods region and also make them virtual. While we'll only be using them when we add animations, I'll also open up the player state machine script. In here, I'll create a new method by typing in public void onAnimationEnterEvent and call in current state dot onAnimationEnterEvent. Then I'll duplicate this method twice and swap enter with exit for the first one, and then enter with transition for the second one. When that's done, we can add the transition to our dashing state. To do that, open up the player dashing state script. In the iStates methods region, start by overriding the onAnimationTransitionEvent method. Inside, we'll check if stateMachine.ReusableData.MovementInput equals to vector2.0 will then transition to our hard stopping state. Of course, we don't yet have it, so let's transition to the idling state instead by typing in stateMachine.ChangeState and pass in stateMachine.idlingState. We can then return. If that isn't the case and we have something in our movement input variable, which means we are pressing a movement key, we need to change to the sprinting state instead. So copy the line above and paste it under the if statement. Then swap the idling state with sprinting state. There is one last thing we need to do, and that's to override the onMovementCancel callback method and leave it empty. This makes it so we don't go to the idling state if we press and release a movement input key. Our dashing state shall now be finalized. Do note though that it will only completely work whenever we add animations to our system. But if we enter play mode, we should at least be able to dash once. Of course, it will never leave the dashing state, which has an higher speed modifier as well.